So welcome to the Git Good, a guide to Git and GitHub workshop. So this is basically the first workshop in the Hackathon Prep series. So basically we're going to have during the mid-semester break hackathon hosted by the CS Club. So hopefully that'll be a fun competition where there will be some prizes. And so hopefully this will be the first workshop to help you prepare for that. So main aim is to master version control and collaborative coding. So hopefully you're already a member of the CS Club. If you don't know, the Duck Lounge is right there next door. There's a QR code events page and a link tree on the right. Firstly, the Ghana acknowledgements. We acknowledge and pay our respects to the Ghana people, the tradition custodians whose ancestral lands we gather on. We acknowledge the deep feelings of attachment and relationship of the Ghana people to country, and we respect and value the past, present, and ongoing connection to the land and cultural beliefs. So firstly, just some quick links. So the first one's a link to these slides so you can follow on. And the next one is the GitHub repo. So it's just a template repo you can follow on. I'll talk more about the repo in a bit. So just try entering those links in. So hopefully open those links on your laptops if you're following on. So firstly, what is Git? So Git is basically a version control system and that tracks the versions of files over time. So you can see like if you make changes to it, you have a backup of what things you change. And it basically allows you to collaborate with other people by enabling multiple developers to work on the same project at the same time. So it's really useful for courses like OOP or like SEP where you have to work on a group project with the same code base, and also manages the project history and all the different branches. And it makes it basically easier to handle different development stages and features. So you can easily add new features without breaking the whole code and having different merge conflicts, which we'll talk about in a bit. So GitHub is basically a web-based platform that provides a hosting service for Git repos, and it allows developers to store the code repos in the cloud and collaborate with others on the same code base. And you can make, if you haven't made one already, you can make one on github.com. So GitHub is basically relies on Git as on the backend. It manages all the different merging of branches and all the some companies use different things as an alternative to GitHub, like Bitbucket or GitLab. And those are more like self-hosted instances, but they basically do the same thing. As a also tip, you can get the student developer pack on GitHub for free, which basically includes a bunch of cool benefits, including a GitHub Pro subscription, as well as like a free domain and other cool benefits. So you can have a look at the added link if you want to get access to those. So the main difference between Git and GitHub, so you can think of Git as basically your local tool on your laptop, and GitHub is just like Google Drive. So you basically have all these changes locally on your laptop, and then you push it to Google Drive to basically back it up and have like a file history. So other differences is Git is open source, maintained by the Linux Foundation, and the software is installed locally on your local device. And it basically tracks these changes to the different files in the folder in a repository, and it provides a command line interface by default, although there's some like GUI options like plugins in VS Code to do the same things. GitHub, on the other hand, is proprietary and it's a cloud-based system and used for hosting Git repos, and provides a web interface to view the files, track issues, and facilitate discussions. And like I mentioned before, it just uses Git in the background for merging all the pull requests and making new branches and stuff. So getting started. So in order to set it up locally, you basically need two things. So you need a name and an email address in Git. So each commit has to be associated with a certain author, including the name and email. So in order to configure this, you can use these commands. So git config -- global just sets it globally, and then you can set user.name for your name and then user.email for your email. So just make sure you match these with whatever you use for your actual GitHub account, just to make sure it tracks all the changes properly, and then it adds it to your like commit history as well. Yeah, so if you want to now to sign in into GitHub, the recommended way is to use the command line interface. So you can get that at cli.github.com. And if you download this, it depends on what OS you're using. But basically, you just run ght-auth.login, and it just follow the prompts to finish the signing in. So there's basically two different options when you're trying to log into GitHub using this. There's either HTTPS or SSH. So HTTPS is more easier to set up and use, but it requires a username and password, although you can use a personal access token, which is more used for like specific like apps or like command line tools. You typically just use a username and password for your local device. And SSH, on the other hand, uses more secure key-based authentication, and it requires generating these SSH keys. So both methods are efficiently managed by the command line tool, but generally SSH is more the recommended way of doing things. So you can just see an example there of setting it up. It gives you an option of signing into GitHub or another like Git instance, and then you just fill in information and then it logs you in. So assume most people will be using Visual Studio Code or VS Code. If you're not, there's probably some similar extensions. But for VS Code, it's really not really like, useful. So GitLens is the first one, which allows you to see the commit history, authorships, and the file changes in line. So you can see in the image on the left, on the top, you can see who changed it and the commit name for it, which is quite handy for like working on group projects to see who worked on that specific line or file beforehand. There's also Git graph. You can see an image here. It basically allows you to browse their branches in history in an interactive graph. So you can see more in a visual fashion of how the changes are merged together. And of course, there's a code spell check as well to help you with typos, which is always nice. Moving on to the Git lifecycle and some basic commands. So generally, there's four main stages of the Git lifecycle. So this is the working directory, staging, local repo, and remote repo. So the first three are basically on your local device, and then the last one is, of course, remote, so it's like on GitHub. So in order to create a repo on GitHub, you can go to github.com, go to the top right and click the plus icon, and then you can create a new repo by selecting the option, and then you just fill in the required information. So you can do things like repo name, description, whether you want the repo to be private or public, There's also some fields for like adding a template, adding a README file, which is basically a description of the project, git ignore, and licenses. I'll talk more about git ignores later on. So if you want to do the create a new repo locally, you can still do this. You basically have to make a new folder and then run git init. So this basically makes a new Git repo and creates all the files required to tracking all this information. But what is exactly in this .git folder? So basically this folder has a bunch of subfolders and holds everything that Git needs to track your project. So when you start off, you'll basically see all the things except the first two. So the first two ones are when you actually make changes, so when you make the commits and stage those changes, the things get added to that. So the folders include the index, so it tracks all the stage changes, logs, which is the history of all the reference updates, for example, when you do the commits or check out new changes. There's a config, which is for repo-specific Git settings, the head, which is basically just a pointer to the current branch that you checked out. And there's some more like the info, which is some extra ignore rules, not really used, and the references, which is pointers to different branches and tags, which is more useful like when you're looking at different contributors on the same code base or looking at forks. It has a bunch of different pointers for that. There's description, which is not really used anymore. There's hooks, which is like optional scripts for automation. For example, you can run like a pre-commit hook, which, for example, you can do a bunch of like linting or formatting to make sure your code follows a style guideline and ultimately formats that when you commit, which is quite handy. And there's also, of course, the objects folder, which stores all the commits, files, and histories. So the templates are basically in GitHub, so they're just pre-configured startup repos, and basically use the similar steps, but you just have to look on a GitHub. If it has this use this template button, you can create a new repo and then fill in the required info, similar to making a new repo. And when you want to clone your repo, depending on how you set it up, you can either do HTTPS or SSH, and you just do git clone and then that address you can copy and paste from GitHub. Okay, so for those following on, there's some like tasks you can like follow on and practice these skills. So the first one is just getting started with GitHub and Git. So you can go to that address, so it's just a basic template repo. And what you need to do is just use this template, clone it, and then open it in VS Code. So here is the GitHub page for it. So basically, click this button, create a new repo, and then you can call it what you want. Basically, already you have an existing one, so you just add a to it. And then you can choose a visibility. So by default, most of these repos will be public, but you can change it private. It doesn't really matter for this case. And then you can create a new repo, and then it takes a few seconds for it to load, process the changes, and then you have your page on GitHub. So now to clone it, you just copy that address, and then you open like a terminal, depending on what you use. If you're on Windows, probably better to use command prompt because PowerShell has some issues with different commands. But you just do git clone and then copy and paste that, and that will just clone the repo. And then and then you can navigate to that folder, and then files are in there. You can also do it directly in VS Code. So if you click the clone Git repo button when you make a new window, you can do you just have to copy the same link and then clone from URL, and then open it, and then you have the files on the left. So hopefully you're able to follow on with that. So moving on, basically the next, I guess the first stage of the Git lifecycle is staging and committing changes. So basically when you edit the files, it's all the changes are basically untracked. So it's just on your local directory, and it just sits there. So staging involves preparing the files to be committed. And it's quite important to know that staging is not the same as saving the history. And that's in fact what the git commit does. So basically there's some commands. So the first one is git add. That basically stages the changes. And then you do git commit to actually save the stage changes to the git history. So yeah, here's the commands again. So you can do git add file names to add specific files. So you can do like git add intro.md to add that file, or you can do git add and then full stop to add all the files in the folder. You can also discard the stage changes as well if you don't want them to be added. So you can do that with the reset command. So git reset file names, or git reset to do reset all the files basically. And then when you're happy with that, you can do the commit command. So you can do git commit -m, which is for message, and then the commit message. So generally, when you're making commits, it's ideal to have them where you actually understand what that commit is specifically doing. So conventional commits is basically just a standard for naming commits and as well as branches, and it generally follows that syntax of type, optional scope, and description. For example, you can have a commit message of feature, DB, and database schema. This people generally use this just so you know what exactly the commit is doing, rather having like commit messages like hopefully this bug is fixed or like, fix a bug, and it's not clear what the bug is, which bug is getting fixed. So there's generally just a bunch of different options for this specific standard. There's like feature, fix, refactor, docs, build, style, CI, and chore. So there's descriptions for all of them there. If you want to learn more about them, there's a link to their website, or you can just Google conventional commits, and I'll tell you more about like how to name all the different commits. Now, remotes is like the last part of the Git lifecycle. So the default remote repository is origin, and in our case, the remote is GitHub. So basically, once you git add all the changes and then commit those changes, you want to push those changes to GitHub. You can do so with the git push command. And there's also some other commands, so like a git fetch command, which basically fetches updates from the remote, so GitHub, but it doesn't actually apply to your current branch. And there's also git pull, which pulls updates and applies them to the branch. And you can have different remotes for forks. For example, if you have like the website repo for the computer science club, there's different contributors, so they fork the repo. So basically, fork is just making a new version of the code base on your own like GitHub instance basically. So basically, there's different remotes. Generally, it's just like a username on GitHub, so you can easily identify the different people. So for forks, the origin is basically your fork, and then the upstream is the original repo that you forked from. So pushing changes, when you want to push the change, you can just do, I don't know why it's said twice, but git push remote and branch. So for example, you can just do git push origin and then the main branch, which is the default branch, and checking remotes. So you can check the different remotes by using git remote -v, and that's just opens Vim. So if you want to exit it, you just press Q. So this basically just lists, like I mentioned, the different remotes. So you can see in the bottom one, there's more remotes because different contributors have the different forks. And you can see if it starts with like git at github.com, it's an SSH. You like clone it with SSH. If it's like starting with HTTPS, you clone it with that instead. You can also do a similar thing for branches. So you can run git branch, and it shows you the different branches on that repo. You can also do it in VS Code. So you can do it in the bottom left, click the little branch icon, and then go on the, opens a prompt, and you can see the different branches listed in the UI there. So Markdown, generally GitHub, lots of repos use Markdown for the documentation, and it's just basically a lightweight markup language for formatting text, and it's just easy to read, in the rule format, and it's easy to write syntax. And yeah, it's quite commonly used for the readme.md, which is like the main readme file for like setting up the project, as well as like wikis and documentations and different GitHub repos. And it basically keeps the documentation alongside the code, and as well as it being version controlled, so you can keep track of any changes. So the README file, like I mentioned, is the first file people see in a repo, and it generally explains like the purpose of the project, the setup, how to use the project, and any contribution guidelines. And it's generally like written in Markdown, and yeah, it helps others understand how to use your project quite quickly, rather than looking at a long list of documentations on separate pages. And generally, it includes basically like project overview of like what your project is, how to install a project, how to contribute, mainly if it's like a public repo, as well as a license info. So the next task, if you're following on, is to make a simple change. So basically, you want to edit the intro.md file, which is a markdown file, by adding your name to the description, and then stage your changes and make a commit, and then push it. So going back to VS Code, you can see the intro.md file is here. Make it bigger. So this is like the general syntax. So there's like hashtags for headings. You can use like hyphens for like lists. There's like check marks for like lists, with like a to-do list. There's like double asterisks for bold, and there's like underscores for italics. And if you want to like preview it, you can right click and click the open preview, and it has like an actual code like in a more human readable format with all the formatting applied to it. So going back to this file, you can just add my name, and then make sure to save your file, and then you can either use the UI by clicking the left and then clicking the plus icon and then staging it, or if you open a new terminal, You see it does the same thing regardless of you doing it through the UI or through the command. It just like syncs it between it. And then now it's staged, so you can run the git commit command. Git commit.
To make sure everyone is following, right?
Yeah. So is everyone like following on right now? Is there any like questions so far, or like any difficulties?
Really none? Even one.
Okay, so I was. Yeah, so after you run the git add command, to add the files, you can do git commit and then do your git commit message. So, for example, you can do doc add name, and then it says one file changed. And you can see in the UI as well, this says sync changes as well, and with one number, so there's like one commit stage. Yeah.
Yo, shut up. That's not very nice, Jason.
Yeah, so now you can actually push it. So you can run git push and a remote, so you can just do origin and then the main branch. It'll take some time, and then it says it's completed. You can do the same thing through the UI as well if you want. So now it's synced to GitHub. And if you go to the GitHub page again for your repo, you can see the commit name is here. And if we click on that, you can see the specific details. So you can see the file changes, which lines you actually changed. So now I mentioned branches before, but what exactly are branches? So branches are basically a lightweight movable pointer to a commit. So you can think of it as a separate timeline for your code. So different, you make different changes and they have different timelines that split. And it's basically used for working on different features, fixes, or experiments without affecting the main branch. And the main branch is usually the default or production code. So basically, you don't want anything bad to happen on the main branch. That's why you work on different branches. So each repo has at least one main branch, and it's usually called the main branch, or like previously it used to be called a master if you're looking at some old repos. So why you want to work on different branches? Mainly because multiple people can, if they work on the same branch, you risk conflicts happening. So for example, in this image, you can see person A makes changes, and then person B also makes changes to the same file in the same lines. And then when you try to git push it, they'll have a conflict since both of them made changes to the same file. So these changes to the same file can overwrite other people's work, and pushing directly to main can basically just cause issues that you don't want to deal with. So that's why it's recommended to work in separate branches. You also have the benefit of having easy collaboration in shared projects as well as keeping projects and bug fixes isolated. And you can also work independently without constant updates from others. So you can work on one feature and the other person can work on other feature, and then you can merge it later on. And you also have the option to have a cleaner Git history. So when you're merging the pull requests, you can have it where you can have just one commit for like a bunch of commits. So it just makes it more cleaner. So in order to create a branch, you can do git checkout -b and the branch name, or you can also do some alternative commands, which is git branch and the branch name, or git switch and the branch name, if you're doing with the command, or you can do it through the UI again by clicking the bottom left icon and then doing create a new branch. So the next task is basically to create a new branch and then switch to it and make sure you call it feature/more info, and then update the intro markdown file to include your city and country and whether you're a uni student, and then commit these changes and push. And then you also want to repeat these same features or same steps for the feature/doc info, and then fill it in with the below information for Donald Duck, the mascot. So the reason we're doing two branches, you can see later on, but it's basically to try to resolve a Git conflict, Git merge conflict. So if you go back here,
I'm nice to this. You don't like to like the presentation. That's like something. I think just do the Is that weird? Why not?
if you're using the command line, you can do git checkout -b, and then we wanted to call it feature/more info, and then automatically switches to the new branch. You can see in the bottom left as well, it says feature more info, so you know you switch to that branch. And then now we want to edit this file again. To edit, just add city, add a country, doesn't matter what specific one, and then you can change the C font as well, and you can see the preview changes as well. And then now you want to I'll show it through the UI instead, so you can save the changes. It shows here like a diff. It just shows like what lines are changed in that file. Same thing, you can make a commit message through this text box here. You can see add city and country, and then you can publish that branch. So now you can swap the branches. So for example, if you're doing it through the UI, if you click the bottom left, it shows the different branches here. So if you want to go back to main, you can just click on that. So now, show again through the UI how to create a branch. You can create a new branch, call it feature doc info, and then it switches to the branch. And then you can change the info to match what was on the slide. And to double check, you can just preview the file. And then same thing, you can add the file as well to stage it, and then you can make a new commit message. So you can do, for example, docs add doc info and commit and publish a branch. And you can use the command here, git branch again. You can see the 3 branches are there. And as well, you can see through the UI those 3 branches. So now, how do you merge these changes? So basically, we make a pull request, often called just shortened to PRs. So basically, signals a branch is ready to merge into the main branch, and it's used for features or bug fixes or whatever really. And it's basically normally merged after a maintainer approves it, and the maintainer is basically whoever owns the repo or who has the access or permissions to. And you can also do this locally with the git merge and a branch name command. And generally, the common workflow when contributing to other repos is forking the repo, cloning it, making changes, and making a new pull request. So when you actually make the pull request, there's 3 different options for actually merging those commits into the main branch. So there's merge, squash, and rebase. So merge is basically combining the branches while keeping the full commit history. So for example, if you have like 10 commits in that branch, it adds all those 10 commits to the main branch. If you do squash, it instead combines the commits into 1 commit before merging, which again is useful if you want a clean history. Rebase, on the other hand, moves the branch changes on top of another branch, which is more for a linear history, if you want it more like in chronological order. So now task 4 is to merge branch. So you want to merge a new branch into the main branch by making a PR and clicking squash and merge, and deleting the branch when done because you don't need it anymore. So make sure you do the feature/more info branch for this one. So if you go back to GitHub, it has these pop-ups here that there's recent pushes and prompts you to make a pull request. So we'll do that for the first one. Generally, you can have a title. Depends on what your GitHub, like if there's any specific style guides and description. Sometimes it's good to have more information, particularly for more complex branches and code changes. For now, you can just do add city and country. And there's also some other features in GitHub. You can have like assignees, labels, projects, milestones, which is better for like project management. That's some other things you could do. If you scroll down, you can see the different line changes for that file. So, for example, when someone's reviewing your work, you can see exactly what changed. So we can click here, create a pull request. So once you do that, it has this prompt here. You can merge the pull request. So there's again 3 options: to merge, squash, and rebase. We want to squash and merge it. You can change the commit message. You can leave it as is. And now it says it's successfully merged. So you can delete a branch since you don't need it anymore. So if you go back on GitHub on the main branch, you can see it made this new commit, which just adds your changes from your branch. So for this example, it's pretty easy and straightforward to merge. But generally, it's not always as easy. So some repos may need you to have more detailed pull request description. So you may have to link to an existing issue on GitHub or other information about what specific files you change. It can also make you pass certain checks. So like I mentioned before, you can have different linting and build checks to make sure your code passes certain standards. And you also might have to get approval from another person or persons by the repo maintainers. And you may also encounter merge conflicts. So merge conflicts basically happens when changes affect same lines in a file on different branches, and Git basically doesn't know what to do with this. So it doesn't know how to automatically merge this. So as a result, you have to resolve this manually before merging. You can do so either on the web editor on GitHub, or you can do it in VS Code. So basically, when you make a pull request, and then it has something like this where there's conflicts. So in order to fix it, if you want to do it on GitHub, you can manually edit the conflicting code. So if you click that previous button, it just prompts you with this web editor with some changes, and it has that difference, so you can see the different code for the different branches. So you have to manually edit that, and you can do a similar process locally as well. You can do so in VS Code or whatever IDE you use. So after you fix those changes, you can make a new commit after resolving that to complete the merge. So next task is to resolve some practice resolving some merge conflicts. So basically, you want to switch the feature/doc-info branch and try to make a new pull request for it, and try to fix the merge conflicts. So going back to the GitHub page, if you click the compare and pull request button again, and make another pull request, it should tell you this branch has conflicts that must be resolved. That's because there's conflicting lines for the intro.md file. So for example, if you want to fix this on GitHub, you can click the resolve conflicts, and then it has this editor and it has these lines. So for example, the first section is in the doc-info branch, and then the second half is in the other branch. For example, we can just move that chunk, and then we can mark it as resolve, and then we can commit the merge. And after that, it should say there's no conflicts, which is good. And again, you can squash and merge the branch. And then you can delete the branch as well, since we don't need it anymore. So there's some more additional Git and GitHub commands and features that you might find useful for your projects, especially like things like oop or like sep. So stashing is basically temporarily saving stages without committing. So it's basically useful when you need to switch branches quickly, which is good like if you're trying to review some changes by another person on the same code base but don't want to actually have any conflicts and actually commit stuff. And it just keeps your working directory clean. So you can use this by running the git stash command, which saves the changes that's applied in the local folder. And then you can do git stash apply to reapply the saved changes. And then you can do pop to reapply and remove the stash, and drop, which deletes a stash without applying it. You can also do it in the UI by going on the left and then going down to stash and then doing whatever option you want. So stashing, you can follow this one quickly. You can just modify the intro.md file, stash changes, and then apply them. So if we switch back to the main branch, and then to get the changes, you can see it's not updated yet, so you can do git pull. So that fetches the changes and then applies it to the current branch. So now it's up to date. So now you can do, you can make a change, you can change it to duck, and then you can run git stash, and then it stashes that changes, and it goes back to whatever it was before. So if you want to apply the stash again, do git stash apply, and then it applies the changes again, so you can actually commit it later on. So there's also some other useful commands, so like reset, which basically moves the head pointer to a previous commit. So it basically allows you to undo commits locally before pushing. And there's 3 different types. So there's soft, which keeps the changes staged, mix, which keeps the changes unstaged, and hard, which discards all the changes. And you have to make sure you use this with caution, as it can rewrite the Git commit history. And there's also revert, which is kind of similar, but it creates a new commit that undoes the changes from a previous commit. And it's safe for undoing changes in more for public or shared branches. And this, on the other hand, does not rewrite the history. So you can practice this. So if you go to intro to MD and make a commit with 2 changes, no need to push them, and then run some commands. So go back here. So for example, you can change like the first name, make a new commit. And make another change. Commit that, and then can use this command git log. So basically, it just has all the commit histories along with the commit IDs, as well as like the author and dates and the commit names. So basically, what you want to do is find the last commit. So you can like scroll down. If you want exit, you can click Q. Go back here. You want to undo the last commit, so you can copy that ID, and then you can do git reset soft, and then the commit ID you can just copy and paste, and then sync it. And you can check the status here. It's just ahead of by one commit. And then you can do similar thing with git revert to undo the one we pushed. So git revert, and then the one we already pushed. So this just reverts the commit. So this just has like the commit name. You can just do enter. And then sync that change. And that undoes a previous commit of changing the last name. And you can check the history again with git log. You can see, so the last name is there. Reverting the last name, sorry, commit is there. And there's also another way you can also cherry pick certain commits. So you can apply a specific commit based on the commit ID from another branch onto your current working branch. So it's useful for grabbing bug fixes or features without merging entire branches. So you can use the git cherry pick and the commit hash command to do so. But it may cause conflicts. So yeah, you would have to resolve them like normal merge conflicts. There's also the .git ignore file as a way to ignore files from getting uploaded to GitHub and getting tracked by Git. So you can exclude files you don't want tracked. So you can use things like temp files or executables that you probably don't need to add to GitHub. So you can use glob patterns, which is basically, for example, an asterisk.exe, which ignores all the exe files. So for example, here's like a template for, I think, C, or C++, one of them, which are the common ones. And there's a bunch of default ones on GitHub. When you make a new repo, you can use those templates. .env files, so short for environment files, environment-specific variables, which are like API keys or configs, and it basically keeps sensitive data story out of the main source code, and it uses simple key equals value format, and it's not committed to Git, and it's added to the git ignore file, and it's used by like apps at one time to configure the settings. For example, this one's like setting up the authentication for the CS5 website. So generally it's a .env file. Sometimes it may have different names depending on what framework you're using or what language. You can also have .env.example, which is pushed to Git, which is just an example format for the environment variables. You can also star different repos. So starring is basically a way for bookmarking different repos you find useful or interesting. Others can, you have to keep in mind the list is public, so others who look at your GitHub profile can see which repos you've starred. You can also use this for keeping track of inspiring projects, since it has different lists as well. And it's also a good way to support open source maintainers and building an own list of useful resources. For example, for SAP, you can use it for finding different code bases that might be useful to make your own project. And generally, this format, your username and then the tab stars, so you can click on the right button, your user profile, and clicking your stars. And then if you go to a project, you can click the star button to actually star it. So for example, we can go to the one of the websites, one of the projects on the CS Club website or any other repo really. You can have a look at. Yeah, if you want to start a repo, you can do like click on the star. You can also have like different lists. So you can call it whatever and then add it to that specific list to keep track of different repos. So here's some more additional resources. If you want to learn more about Git or GitHub, so there's some good resources on the actual Git website as well as Atlassian and the GitHub repo, GitHub website itself. So also the open source team. So since it's quite correlated to GitHub, I thought I'll mention it. So open source is basically any software that source code that anyone can inspect, modify, and enhance. And it promotes collaboration and transparency, allowing developers from around the world to collaborate on cool projects. So there's a bunch of different licenses for it. So generally there's the permissive or the copyleft ones. So main difference is the copyleft you can use it for closed source projects. But basically these open source projects promotes innovation and community-driven development. Like I mentioned before, the open source workflow is slightly different. But basically you fork and clone a repo, create a new branch from main, following the README to set up the project, working on an issue that you want to work on and push your branch to your fork, and then creating a pull request with a clear title and description. And then hopefully if it has like status checks, hopefully it passes all of these, otherwise you have to try to fix it. And then after that, you can wait for review and approval from the project maintainers. And then once approved and checks pass, your pull request will be merged. So also the CS Club has an open source team led by myself. So we have a bunch of different open source projects, including the website, a Discord bot, my timetable, and a bunch of others. So there's a bunch of websites as well as a custom voxel game engine, which is pretty cool. And there's many other exciting projects planned ahead. There's also website links to our website and GitHub there. If you want to learn more. If you want to join, we're always on the lookout for any people who want to join. So if you want to express your interest, you can just fill in this QR code to take you to an application form. And the general process is filling this in, doing a short technical assessment, and then doing a quick interview just to see if you can commit to the time and to see some basic coding skills. Just also add here, the CS Club is running a quiz night this Friday. So if you haven't signed up already, it's a good opportunity to use your brain art and other chronically online stuff. Yeah, by Tim, hosted by Tim at 5:30 in Union House. So if you don't have a ticket, make sure you go to the link eventsofhumanitics.com/Timothy.
My own referral code.
Yes.
Timothy.
So there's also a link to a feedback form for this event. So if you have any feedback on how we can improve it or anything that went well, we would really appreciate your feedback by scanning that QR code. So is there any other like general questions about Git and GitHub or anything else that anyone else had? No, I think everyone's waiting for food, I guess. So I guess we'll end the workshop here. So thank you for everyone who's coming, who came here. And